Okay. In the last class we have seen about the introduction about our subject, that's the digital system design using a Verilog. Okay. Today we'll start with the actual syllabus. Okay. Start with the first chapter, that is the overview of the digital design system with the Verilog HDL. Okay. In the last class we have seen the introduction brief evolution of CAD tool, evolution of the CAD. Okay, how the evolution of the CAD need to come into existence. Okay, CAD is nothing but the computer aided design digital design system, computer aided digital design tool. This is the tool how it has been emerged. Okay, so today we'll see the same today also, because I left with some more topics over that. Over the 25 years back, this a CAD tool was invented. This is the tool which is used to design our digital design system. Okay, the digital system was involved, and also earliest the digital system were designed with the help of what the vacuum tubes. Vacuum tubes and the transistors. Okay, usually the digital design systems usually designed with the help of what these vacuum tubes and the transistors. This is the my digital design system is the very simple. If it is like a AND gate is also one of the digital system. Okay, this is also one of the digital system. This can be implemented with the help of what the transistors only. How the transistors are used to implement this one, we'll see. That one as the, if I have the AND gate purpose, one transistor, first we'll see the NOR gate. That's the NOT gate is the one of the switch. It is also working as the switch. 0 idre on agutta, 1 agutta, 1 idre 0 agutta. So that switches can be implemented with the help of the transistors. As the transistor is we have the two types of transistors. One is the NPN transistors, another one is the PNP transistors. Okay, this is what type of transistor we have here. NPN or PNP. NPN transistor or PNP transistor. NPN transistor, because of the N is the outside, this is what the P. Wherever the this arrow mark is there, that is what the N, and also it's the emitter. It's also emitter. Okay, this while using this transistors, we can implement our NOT gate here. How can I implement? Using the one resistor. This is what the VCC, and also here I am supplying the input through the one more resistor here. If I am sending the signal, okay, this is what the 0 to 1 signal through what the one resistor. With this transistor can act as what now NOT gate here. Okay, that's the output is the what the Q equals to A equals to 0 idre enagutta, Q equals to what the 1. It's working as a inverter. Usually these gates almost all NOT gate and AND gate, NAND gates, like this. Similarly, so many gates. While using the gates, these gates can be implemented with what the transistors, even with the vacuum tubes on the breadboard. Usually breadboard, you see no breadboard. Breadboard on gottilla. Breadboard ಅಂದ್ರೆ ಕನೆಕ್ಷನ್ ಪ್ಲಾಟ್ಫಾರ್ಮ್ ಇರುತ್ತೆ, ಅದ್ರ ಮೇಲೆ ನಾವು ಟ್ರಾನ್ಸಿಸ್ಟರ್, ರೆಸಿಸ್ಟರ್ಸ್ ಮತ್ತು ಯಾವುದೇ ಒಂದು ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾಂಪೋನೆಂಟ್ಸ್ ಹಾಕಿ ನಾವು ಟೆಸ್ಟ್ ಮಾಡಬಹುದು ವಿತ್ ಅಪ್ಲೈಯಿಂಗ್ ದ ವಿಸಿಸಿ ಕರೆಂಟ್ ಸಪ್ಲೈ ಮಾಡಿ ಅದ್ರದ್ದು ಔಟ್ಪುಟ್ ಮಾತ್ರ ನಾವು ಸಿಆರ್ ಅಂತ ಇರ್ತದೆ. ಸಿಆರ್ ಅಂದ್ರೆ ಎಲ್ಲ ಸಿಗ್ನಲ್ಸ್ ತೋರಿಸ್ತಿರ್ತದೆ, ಆ ಟೈಪ್ ನಾವು ಟೆಸ್ಟ್ ಮಾಡಬಹುದು. ಓಕೆ, ದಟ್ಸ್ ಟು ಬಿ ವಾಟ್ ದ ಮ್ಯಾನ್ಯುವಲಿ ವಿ ಆರ್ ಡೂಯಿಂಗ್ ಹಿಯರ್. ಮ್ಯಾನ್ಯುವಲಿ what the single circuit we are designing here. If it is my circuit is what the very complex, somewhat complex, then I will go with what the somewhat designing process will be what the changes over here. Changed here. The thing is here the first commercial IC was invented in the 1960, and these okay, whatever the things, these digital design systems to be implemented on what the on a circuit, on a what the ICE integrated circuit, okay, on an integrated circuit. Usually if my circuit is very simple, then I can do what these things are on the what the breadboard itself or the interconnection wires. If my circuit is becoming very complex day by day, my circuit is my requirement is becoming the very complex, then then definitely I cannot implement on the breadboard. I cannot implement on the breadboard. If it does, so that I have to go with what the integrated, these types of circuits can be implemented on what the ICs, what the integrated circuits. Okay, this can be this is done on the in the era of what the 1960. Similarly there are four generations of ICs are come into existence. One is what the first generation ICs, what the first generation ICs are called what the SSI. SSI is nothing but the small scale integrated circuits. This is the what the small scale small scale integration. These type of ICs are used to only within a less than the 100 transistors. Means for the NOT gate, AND gate, somewhat like gate level designing. Gate level the gates, AND gate, the NOT gate, the NAND gate, the OR, the XOR gate, these type of gates I can implement and with the help of the ICs. This type of ICs are called what the SSI. SSI is nothing but the small scale integrated circuits. These are ICs SSI ICs antivi. One way ICs are implemented to be what the more than the 100. These to be what the less than the 100. For example for this are the what the gates, logic gates usually implemented with the less than the 100 transistors here, less than the 100 transistors. NOT gate ಎಷ್ಟು ಬೇಕು ಟ್ರಾನ್ಸಿಸ್ಟರ್? ಒಂದೇ ಟ್ರಾನ್ಸಿಸ್ಟರ್ಸ್. ಒಂದು AND gate ಬೇಕಾದ್ರೆ 3 ಟ್ರಾನ್ಸಿಸ್ಟರ್ಸ್ ಬೇಕಾಗ್ತವೆ. NAND gate ಅಂದ್ರೆ 2 ಟ್ರಾನ್ಸಿಸ್ಟರ್ಸ್ ಬೇಕಾಗ್ತವೆ. Depending on the what type of gates I am using here. This to be what comes under what the SSI means what the small scale integration ICs only. This is the ICs. Okay, this is what the ICs. Okay, next is what the second generation ICs. This to be called as what the medium scale integrated circuits. MSI is nothing but the medium scale integration ICs. Okay, these to be this type of, okay, these to be we will be using the more than the 100 means what the more than the 100 means what the less than the thousands, more than 100 transistors I am using here. More than 100 transistors I am using means what less than the 1000. Okay, this to be example for this to be what the counters, flip-flops, what the and even the latches you have studied in the last DSDV subject. In the subject, counters, flip-flops usually designed, okay, designed with the help of what the some other logic gates. Means what the here I need what the more than the 100 to 1000 transistors I need to implement this type of ICs here. Okay, next is what the third generation of ICs. Third generation of ICs. Okay, this is what we call the LSI. LSI is what the large scale integration circuits. With this to be having the more than 1000 IC transistors are used to implement such a electron circuits. Okay, for example, this type of circuits to be what the like some other like not the flip-flops, like a counter. So such a ICs, such a circuits to be implemented with what the large scale integrated circuits. It means here I need the more than 1000 transistors to implement such a circuits. Okay, if I go with the more than this type of circuits, if my requirements goes on increasing, then definitely I can build with the other type of circuits that's we call the very large scale integration circuits. That's what the fourth generation fourth generation. Up to here, I can design the digital circuit using what the transistors, and even the I can synthesis. Even I can synthesis with the synthesis usually, and this to be implemented on what the ICs we call what the LSI, large scale integration circuits. This to be done if it is EDA tool. It's nothing but the what the electronic design automations. That's we call the electronic design digital automation. This to be done with the what the ಈ ತರ ನಾವು ಡೆಡ್ ಬೋರ್ಡ್ ಮೇಲೆ ಮಾಡೋದ್ರಲ್ಲಿ ಏನ್ ಮಾಡ್ತದೆ, ಇಡಿಯಾ ಟೂಲ್ ಏನ್ ಮಾಡ್ತಾ ಆಟೋಮೆಟಿಕ್ ವಾಟ್ ಆರ್ ದ ರಿಕ್ವೈರ್ಮೆಂಟ್ಸ್ ನಾವು ಕೊಟ್ಟಾಗ ಏನಾಗುತ್ತೆ ಆಟೋಮೆಟಿಕ್ ಆಗಿ ಡಿಸೈನ್ ಮಾಡ್ತದೆ ಅದು ಡಿಜಿಟಲ್ ಸರ್ಕ್ಯೂಟ್. Okay, without manual intervention. But if the design is getting more and more complex, and here the can be synthesis can be done manually here up to here. But as the design of the digital design circuits becomes more and more complex, definitely I'll go with what the very large scale integration circuits. That's the VLSI, very large scale integration ICs. Okay, very large scale integration ICs. Here the complexity of the digital circuit is what the more and more. Yeah, here these types of circuits to be designed usually what the we calls what the CAD tool, that's the computer aided digital design tool. Okay, this is what the one of the tool which is used to implement the complete digital design system using what the CAD tool. Here the CAD tool is the one which will be, if you give any requirements like this, I need such a circuit, then definitely the CAD tool will design the circuit automatically with the help of the transistors and also interconnection wires and the resistors. These type of resistors we call what the RTL. Okay, that's nothing but the resistor transfer level. These RTL schematics to be done with the help of what the CAD tool. These RTL schematics are usually simulated, means what the simulated means tested whether the functionality of the ICs, whether the functionality of my circuit is working properly or not. This to be done synthesis with the help of what the synthesis while sending what the inputs combination as 0001 1011 combination. If my gate is what the AND gate, that's the digital circuit is very simple one. AND gate can be implemented with the 3 transistors and 4 resistors. This we call the RTL. That's called, this is the resistor transfer level. Okay, this design is called the what the, this is also RTL. This is also RTL. This is also RTL. This is the RTL is the resistor transistor logic. This is what the resistor transistor logic here. Now this one I am what is at the synthesis level I am using what the RTL schematics, means what the resistor transfer level. Okay, these RTL schematics can be checked, means verified. Okay, whether it is working properly or not. This is to be done with the help of what the using the synthesis. It will automatically synthesis. It will automatically generate the what the test benches, and also it will give the response output automatically with the help of what the waveforms also, whether it is working properly or not. If it's my circuit design is wrong, okay, definitely it will give the errors also. This is all about the, so that here the evolution of the CAD tool. Yeah, CAD is nothing but the what the computer aided design digital design tool. Means what the computer aided digital design tool is to become into existence only when we are getting the more and more complexity in the digital design system designing. ನಮ್ದು ಡಿಜಿಟಲ್ ಡಿಸೈನ್ ಸಿಸ್ಟಮ್ ಏನು ಡಿಸೈನ್ ಮಾಡಬೇಕಾದ್ರೆ ಬಹಳ ಕಾಂಪ್ಲೆಕ್ಸ್ ಬರ್ತಾ ಇದ್ದಾಗ ಅವಾಗ CAD tool come into existence, means computer aided digital design system come into existence. It will definitely, the CAD tool will generate the RTL schematics, and also it will give the it will do the synthesis also automatically. That's what the evolution of the CAD tool come with this. Okay, if this is the one of the question, this is not at all asked still now in the examination last 5 to 10 years. ಈ ಕ್ವಶನ್ ಕೇಳಲ್ಲ ಇಲ್ಲಿವರೆಗೂ, ಬಟ್ ನಿಮ್ಮ ಹಣೆಬರ ಕೇಳಿದ್ರೆ ಗೊತ್ತಾಗಲ್ಲ. ಇಲ್ಲಿವರೆಗೆ ಕೇಳಿಲ್ಲ, ಒಂದೇ ಒಂದು ಕ್ವಶನ್ ಇದ್ರ ಮೇಲೆ ವಾಟ್ ದ ಎವಲ್ಯೂಷನ್ ಆಫ್ ದಿ CAD ಟೂಲ್ ಮೇಲೆ ಕೇಳಿಲ್ಲ. ಓಕೆ, ಇಫ್ ಇಸ್ ಆಸ್ಕ್ಡ್ ಇನ್ ದ ಫಾರ್ ದ 5 ಮಾರ್ಕ್ಸ್ ಕೇಳ್ತಾನೆ ಅಷ್ಟೇ ಕೇಳಿದ್ರು. ಓಕೆ, This is all we seen in the last class. Okay, today we'll go with what the one more topic that we call the emergence of the HDLs.